Hey guys, this is Megan again from OnlineMathCircle AIME video tutorials, and today we're going to look at 2009 AIME I, problem number 10. The annual Interplanetary Mathematics Examination, or AIME, is written by a committee of 5 Martians, 5 Venusians, and 5 Earthlings. At meetings, committee members sit at a round table with chairs numbered from 1 to 15 in clockwise order. Committee rules state that a Martian must occupy chair 1 and an Earthling must occupy chair 15. Furthermore, no Earthling can sit immediately to the left of a Martian, no Martian can sit immediately to the left of a Venusian, and no Venusian can sit immediately to the left of an Earthling. The number of possible seating arrangements for the committee is n times 5 factorial cubed. Find n. So, in this problem, let's first look at the value of n. And here, n represents the number of ways to arrange the committee members with only regards to race. Only regards to race. And the reason why we have this is because the total number of possible arrangements for the committee's individual members is n times 5 factorial cubed, and the 5 factorial cubed part represents the number of permutations of each of the separate race groups. With since we have 5 of each of the races, and looking at the restriction here, we see that a Martian must occupy chair 1, and an Earthling must occupy chair 15, and the chairs are from 1 to 15 in clockwise order. And we have the condition that Earthlings may not be to the left of Martians, Martians cannot be to the left of Venusians, and Venusians cannot be to the left of Earthlings. That means from chair 1 to chair 15 clockwise, the seating of all the races must go in the following order: Martian, Venusian, Earthling, Martian, Venusian, Earthling, and so on until we get to chair 15, in which chair 15 must be occupied by an Earthling. So let's proceed by doing some casework here. First of all, let's look at case 1, where we have one group or block of committee members per race sitting around the table. If we have this case, then we have a group of 5 Martians, then 5 Venusians, then 5 Earthlings, from chair 1 to chair 15 clockwise. So that means we only have one race arrangement in this case. Now, let's look at case 2, where we have 2 groups per race. The number of arrangements possible in this case is correspondent to the number of ways that we can partition the number 5 into 2 parts. So, by doing so, we see that 5 can equal 3 plus 2, or 4 plus 1. Each of these partitions can be ordered in 2 ways, which means that the total number of grouping arrangements for each of the races is 2 plus 2, or 4. And so the total number of arrangements in this entire case would be 4 cubed, or 64 arrangements. Now for case 3, let's look at where we have 3 groups per race. So we need to find the ways to partition 5 into 3 parts. And by doing so, we can have 3 plus 1 plus 1, or 2 plus 2 plus 1. Each of these with 3 permutations. And so that means the total number of arrangements possible in this case is 3 plus 3 cubed, which is 216. Now, case 4, we will now have 4 groups of race. And if we want to do this, we have to partition 5 in 4 parts. And there's only one way to do that, and that's 2 plus 1 plus 1 plus 1. So that leaves us with a total of 4 cubed, or 64 arrangements, since there are only 4 ways to permute the partition parts of 5 in this case. Now looking at case 5 with 5 groups arrays. That means the table must have 1 Martian, 1 Venusian, 1 Earthling, 1 Martian, 1 Venusian, 1 Earthling, etc. From chair 1 to chair 15 going clockwise. So clearly there would only be 1 arrangement here. So looking at all 5 cases, 1, 64, 216, 64, and 1, we just have to add them all up to get the value of n. And by doing that, we get 344 plus 2, which is 346. And so in this case, we have n equal to 346.